today video series, or I would say in today Snowflake tutorial, we are going to discuss about the Snowflake architecture. We will go in depth of this topic, and I'm sure that by the end of this video, we will have a very good understanding of Snowflake architecture. What are different components Snowflake have? What are the use of those components and how those components are built? And what are those features, or I would say functionality, which Snowflake have, which make this architecture highly available, endless scalability, and that is the reason Snowflake is a leading you know database in the market right now. So I would not say database. So basically Snowflake itself is a I would say it's an ecosystem which fulfill enterprise application project or enterprise organizations end to end requirement, whether it's a ETL pipeline, whether it's a storage layer, whether it's a database engine, everything this Snowflake as a whole take care of all the functionalities which are required from data ingestion till data consumption. So this is not right to say that Snowflake is a database. I would say Snowflake is a ecosystem which fulfill any enterprise organization requirement from data ingestion till data consumption layer. Yeah, so we will go deep dive. So just to show basically how it looks, this is the architecture of Snowflake. We have cloud service on top, then query processing or virtual warehouses in the middle, and then at the bottom we have data storage layer. If you guys don't have much understanding of what is these layers, how they works, what is the feature of all the individual layer, so no need to worry. We will go very, very deep dive into all the three layers, and as I said, by the end of this lecture or this tutorial or this video, we will have a very good understanding of all the three layers. And I'll try to make this session, with a whiteboard type of session, so that we will have you will, basically I will be writing about each service layer to get more insight. I will not be going through PPTs or slides. I'll try to go deep dive with the whiteboard sessions. Yeah, so let's go. So, okay. Now, as I said, as we have seen, so basically Snowflake, we have three layers. So just now we have seen we have cloud service. So guys, you can please excuse me with the writing, so you can bear with me, but I'll make sure this writing won't impact our technical discussion. Yeah, so on top we have cloud service. Then down we have compute layer. Then the bottommost is storage layer. This is what we have seen just now. So before we go deep dive into each of these layers, so let me tell you what is basically this Snowflake. So guys, basically this Snowflake, I will just put SW Snowflake. This is a SaaS offering. We no need to spin any infra. No physical, server, or I would say storage onboarding. No networking. Very, very least human intervention. Yeah. So we all knows like the benefit of SaaS offering. Most of the SaaS offerings are built with the idea of pay as you use or you go. Pay as you use. We'll put like this. Yeah. We need any SaaS service for 1 hour. We just use for 1 hour and we pay for just 1 hour. This is how even Snowflake works. Also, before we go into individual layer, so there are some important pointers which just I want to just put up front. With this SaaS offering, so this Snowflake is available or offered on AWS, Azure, and GCP. So as per individual team capability or their existing workload, so wherever they are running, in that same hyperscaler, we can choose any one of them. Right. If you want AWS, you can select the AWS as the cloud service provider and then select the region and create your account and start using it. Best practices where you have other workload. If you have other workload, your applications or your existing applications, let's say they are hosted in Azure, in India, let's say somewhere in central India, right? So best practices, spin your Snowflake in same Azure, India region, central India. This will help your application to interact with Snowflake more efficiently and latency will be very less. Yeah. Now let's go deep dive. Now we will start with the cloud service layer. So guys, this cloud service layer, this is the brain of Snowflake. Yeah. So just think of, okay, so we will have a question, okay, this is the brain, that is fine, but where this is hosted? Do as a consumer or as a user, we will have access to this cloud service layer? No. We will not have access to this cloud service layer. So basically, cloud service layer, these are the set of many services which Snowflake is running. Many services. And all these services are running on some VMs. And all the high availability, is internally taken care by Snowflake. So we are not bothered about this cloud service layer as a user. because we don't have access. This is created automatically. Yeah. So as I said, internally, this will be running on VM with many set of services. And this high availability is maintained with the native architecture of cloud. Since I said this is a SaaS offering on AWS and Azure and GCP, right? And all these services, all these hyperscaler, basically they provide 99.99959, right? Or somewhere 99 high availability for most of these services, right? So same way, you no need to worry about this. We will have a question if my cloud, this cloud service layer goes down, no chance. No, this will even goes down. We will not come to know, and the failover will be transparent to us, right? All this is taken care by Snowflake. Now, what is the use of this cloud service layer? See, this cloud service layer basically, whenever any user or application make a request to Snowflake to insert any data or to pull any data, that request for goes to your cloud service layer. This is where authentication is first done. Whether the user or that application are having a access to Snowflake and what kind of access and how much access they have, right? So this is done and checked by Snowflake. So first is, I'll just write it here, RBAC or authentication. Now, this cloud service layer, this also have metadata information about the tables. So we will write metadata, right? Along with that, this also have cloud service also have information about micro partitions. Info. What is this micro partition? We will study when we will discuss about the storage layer. Yeah. For SQL queries, it does syntax check. It create optimal path to access the data. So basically what we can do is cost-based optimization, syntax check, right? Now, whenever any user make a request to create some virtual warehouse, that orchestrations also happen from cloud service. So, orchestration, right? So whenever we make a request of creating a virtual warehouse, that request goes to cloud service. Cloud service internally is calling a APIs of hyperscaler for spinning up the EC2 instances if it is AWS, or the virtual machine if it's your Azure, right? So all this orchestration automation is done by this layer. Got it? Now, security access control we have checked. Encryption. When all the data which is transferring between the cloud service or the virtual machines or the storage layer, all this encryption is taken care by cloud service layer. So we can put it like encryption. Right. Then, so along with that, there are many other, you know, uh, things which this cloud service take care of. So basically, as I said, this is the brain, right? Do we have cost of using it? Yes, cost is associated, but not upfront. There are some rules that we are going to discuss. Probably I am going to make a one more video which is related to cost only. So in that video, we will discuss, what are different cost which is associated with cloud services, how Snowflake charge, and how much it is charged. So we are going to discuss everything in that video which is related to cost and how to optimize that. So yes, cost is associated since, as I said, this cloud service is a set of many services which are running on this layer for different purposes. Right? For example, if you have a clustering, auto clustering is there, that auto clustering also done by this. If you have a materialized view, then materialized view refresh is also done by this, right? There are many, you know, features which this service does behind the, scene to automate many operational things. And yes, there is a charge associated with this, and we will discuss how that costing is there. Now, okay. Second is, now let's discuss about the storage layer. So virtual machine, this virtual warehouse, we will discuss at the later, but let's start with the storage layer first. Storage layer, we have seen right in the starting of this video, this sits at the bottom. Okay, before that, I'll tell you this Snowflake architecture, or in Snowflake architecture, your storage and virtual warehouses are isolated from each other. We can have a multiple warehouses. For now, you can consider warehouses as the virtual machines. This is one virtual machine 2, virtual machine 3, virtual machine 4, and this storage layer will be shared among all those virtual machines. So basically, all these virtual warehouses or virtual machines for now will be pushing and pulling data from the shared storage. But they are independent of each other. If these goes down, there is no impact on this storage. And and uh, uh, and we will discuss more about this virtual warehouses. What are these basically? But both are isolated from. If you want to scale your virtual warehouses, you can scale them independently of the storage. There will not be any impact on storage. So if you want to scale this up, you can scale this up. You want to scale this up, you can scale this up. There will not be any impact on this storage. Yeah. So, so as I said, these are independent of each other. Now storage layer, right? Basically, we have seen in our on-premise systems, basically we have a SAN storages, right? Or high performance costly storages attached to our DBs server, right? So let's say we have some SQL database. Let's take example of Oracle. We have this Oracle DB engine. This is some physical server. Now to this physical server, we will attach some SAN storages. Correct? And these are very costly. They are high performance storage, so they are very costly. So here, this storage layer, these are not SAN. These are not SAN. What they are? They use cloud storages, or I would say object storage. As I said, this is a SaaS offering and you have a flexibility to deploy them in any cloud provider or hyperscaler, right? So this cloud layer also, so let's say you are deploying on Azure. You have you choose the Azure for your Snowflake account. Then in Azure, it will be a Azure Blob Storage, which Snowflake will use to store your data. Right? And the benefit is all these storages, all these cloud storages, they comes with infinite scalability, right? Very high throughput. Right. Third thing, very cheap. Got it. So, what we came to know? First, they use cloud storage. Second, the benefit is infinite capacity. Third, cheap. Fourth one, resiliency, right? So let's say we choose Azure somewhere central India. Within that center area, in one region, we have a concept of multi-AC, AZ1, AZ2, AZ3, right? When we choose this region for our Snowflake account, all this data which is sitting at Azure Blob Storage will internally be write to all the three AZs, which make this highly available and highly resilience. If these goes down, still we have this. This goes down, still our data is copied internally to this. Right. This is where we have 99.99 durability concept from the cloud. Got it. Now, how data is organized? Okay, so let's say we have a this 5 GB file which is coming as a part of some, let's say, batch processing, right? So what Snowflake does? Snowflake have a concept of micro partitioning, compression, columnar format. All these three Snowflake utilize while saving this 5 GB data. First, it will do the micro partitioning. Micro partitioning means it will divide this 5 GB to small chunks. It can be from your 50 MB to 500 MB. Then it will compress them and store them in a columnar format. All these three things combining together make Snowflake ideal for your data warehousing scenario. Also, so this micro partitioning will help in the partition pruning for the fast data processing. Compressor will help in your cost. Since data is compressed, it will consume less space on the storage. Again, this columnar also for easy and fast access, which is an ideal concept or ideal storing format for any data warehouse application. Right? Also, once this data is written, as I said, this is, let's say, your storage account, your storage layer, and it's a S3 storage on Azure. So once your data is written in micro partition, let's say this is one micro part like this, just the imaginary, I'm doing it. These are small chunks. And internally, this will be mapped to some table, right? Because you will be writing to some table only. You will be inserting data to some table only, right? So all this data internally will be mapped to some table. So now this is micro partitioned. This is the initial load. Now you want to select out of this micro partition, which is your 5 GB of data, and you want to just do the select for some data. Let's say this 5 GB of data, you have this data for IDs equal to 1 to 50K. Now you want to access, you are doing select star from some table where ID equal to 2. Now this data is for IDs starting with 1 to 50,000, right? But out of this, you just need a data for ID equal to 2. Now the beauty is, instead of scanning all these partitions, all this micro partition, our cloud service layer is already having information that where this data for ID equal to 2 is sitting. Where is the no? It is sitting on the cloud service, right? So let's say our cloud service layer knows that it is sitting, this is for ID equal to 2, this is for ID is equal to 2, this is for ID is equal to 2, this is also for ID is equal to 2. So it is going directly when you are doing a select star from table where ID is equal to 2, we are going to get the address of this micro partition which represent ID equal to 2. So instead of scanning those so many micro partition directly, it will read this micro partition, this micro partition, this micro partition, this micro partition, and return back the data. This is the one thing. Now another part. Now let's say we did a update statement. Update tbl1 where or we wrote set department equal to 101 where IDs in, let's say 2, 4, 6, 8, so on. So what we are doing is, let's say organization is merging some departments, right? Earlier for these IDs 2, 4, 6, 8, and so on, the IDs for the departments were different, but now let's say some department are merged. So they are now becoming a part of 101, right? So with this update statement, so what Snowflake will do internally, it will not overwrite. So let's say now 2, 4, 6, 8 are represented by, let me take new pen. Okay, just 1 second. So let's say this is ID equal to, this represent 2, this represent 4, this represent 2, this is 4, this is 6, this is 8, just for the, just getting into this. So what Snowflake will do, it will mark these records as stale. This will not delete. This will mark it as stale and write the new records here. Why it will do like this? There is a concept of time travel. What is this time travel? We will just get into this, probably next video. I'm going to make on all the features which Snowflake provide. So just to give on very high level, so it's basically what happens. So let's say you want to go back to this state. So Oracle, the Snowflake can immediately point it back to these micro partitions, right? So in normal scenario, like in normal, before we were not having a this kind of system, we used to take the backup and then from backup we need to restore back, right? But this will be very quick, probably a seconds. In seconds we can roll back from here to here. So that is the reason it never. So basically we are going to set it for how long we need to keep this stale data. For that period you can have your data not deleted. Yeah. Now comes the, so we have done that. Data is again in storage layer, it is encrypted, which we say is encrypted at rest, and no need to, what is that, worried about the data which is sitting here. It's encrypted, it's safe, and all those things is automatically taken care by Snowflake. Got it? Now virtual warehouses. Okay. So now virtual warehouse. I'll change the pen. So virtual warehouse, basically this is the compute, you know, power. Well, I would say this is the muscle power. Yeah. As I said, your virtual warehouse and cloud storage layer is independent of each other. So what are these virtual warehouses in Snowflake? So you can think of them as a VMs or EC2 instances in AWS, VMs in Azure, and on top of this, it's a Snowflake DB layer. Right. Now, the sizing. So normally in our on-premise, whenever we are, spinning any virtual machine, we check, okay, do I need to spin a 2 core machine, 4 core machine, 8 core machine, right? This is what basically we do. But here, it's not a concept of machine here. It's a t-shirt sizing, which Snowflake follows. So sizing is defined by, or they follow t-shirt size. It start with X small, goes to small, then medium, large, and it goes till 6x large. And the consumption, it's a credit based consumption. For example, for 1x small, the consumption is 1 credit per hour. Small, it is 2 credit per hour. For medium, it is 4. Large, it is 4 to ja. Yes, yes, yes. For large, 8. Basically, it doubles. It doubles. Billing. So this is credit based. So how we get a credit? So again, it's a separate topic. But just consider, you create an account. Let's say you will get some 600 credit. You ran your VM for, let's say, 2 hour. Your 2 credits will be charged for virtual machines. Right. There is a one more thing. 2 credits will be charged, but billing is on second basis. Right. So let's say you created one VM virtual warehouse. So let's not talk about now virtual machines. Let's speak in Snowflake convention. So it's a virtual warehouse. You spinned one virtual warehouse, you ran it for 2 seconds. You created another virtual warehouse, you ran it for 55 seconds. You created one more virtual warehouse, you ran it for 65 seconds. So how you will be charged? For 2 seconds, you will be charged minimum for 60 seconds or 1 minute. For 50 seconds also, you will be charged for 60 seconds minimum. For this 65 seconds, you will be charged for 60 seconds plus 5 seconds. So what we are getting is minimum you will be charged for 60 seconds plus after that it will be per second basis. This is how basically you will be charged. So it's 1 credit per hour. So 1 credit per hour, basically you can do 1 credit per hour. So for 1 by 3600 per second, something like that, if I'm not wrong about this calculation. This is how basically you will be charged. Some round figure probably, maybe. Right? Now, t-shirt sizing we have seen, how they are charged. We have seen scaling. We can do vertical scaling also, starting with X small till 6 large or more. We have few more, bigger virtual warehouses which we can create more than that, but just from the architecture perspective, you can think of X small to 6L. You can do vertical scaling. This is scaling up. For scaling out or horizontal scaling, right? You can create multi-cluster, multiple virtual warehouse. Got it? And it will be of same size. Yeah. Up in that also you have policies. You can define the policies also. The standard policy and economy policy. With standard means spin new cluster when queries queue. And economy, it says wait until the system estimate to keep the new cluster busy. Busy for at least 6 minutes. So these are basically 2 policies you can set. In first standard policy, as soon as you run 1 query, you run second query, query 3, you have virtual warehouse. Your query 1 and query 2 consume this 100%. Immediately, it will start a 1 more virtual warehouse for your third query and your third query. In economy, it will wait whether spinning up new virtual warehouse for this query 2 is going to make him busy for 6 minutes or not. If not, this query will also go in queue to virtual warehouse 1. Got it. Virtual warehouses add 70% to our cost. So designing of these virtual warehouses is very, very important. Got it. Also, this virtual warehouses comes with their local storage also. So you ran one query, one SQL query, you ran it. So whenever it is pulling a data from your storage layer, for temporary purpose, it will keep this data on this VM at their local storage. So whenever user 2 is running same SQL query and there is no change in the data, user is going to get the data from this local storage only, which is there instead of hitting the storage layer, which makes this query very fast when you are running it second time. Got it. So it is not always a best practice that you created one VM and then just sorry. It is not best practice that you created one VM and immediately deleted this. As soon as you delete, this data which is cached will go. You will not get the benefit of the caching. So it is best practice. So basically all these parameters are there which you need to keep in mind when we are designing the virtual warehouse or application, as a overall. Got it. Now, so I'll just give a one flow how basically one query will work in this whole ecosystem. We have this SQL select star from table. First syntax check. Execution plan. Micro partition data. All those things will be taken care by your cloud service. With this micro partition data, cloud service will tell that okay, for this query the data is there at address block number or at block number 50, 51 or 52. It will pass this information to the virtual warehouse. Virtual warehouse will check, okay, do I have this data for this micro partition at my local storage? And it is not changed. If it is there, it will return to cloud storage. Cloud storage will return to user. If it is not there, then it will go to storage layer, where I have data in micro partitions, right? Now, virtual warehouse is already having an information where this ID is collected from table 1, where ID equal to 206. So now virtual warehouse is already having an information that I need to pull data from these address. So let's say this is 50, 51, 52. Virtual warehouse will just read these blocks. It will do all this aggregation and returned it back to cloud service layer. Cloud service layer will return this to user. So guys, as I said, cost is very important for any project to success. That is the reason many companies and organizations struggle when they goes to SaaS models. But if we have a good understanding where or to which components this cost is associated and how to fine tune them, we can make the maximum benefit of SaaS services. So in my next video, we are going to cover this cost associated with Snowflake system in depth. We will cover everything which are those components where this cost is associated. Which are those features with cloud service layer provide and cost is there. Virtual warehouses, how cost is there. Storage layer, how cost is associated, and how to bring them down, and best practice. Till then, guys, stay tuned with me and we will connect very soon. And I'll come with this cost, associated with different layers. Till then, guys, thanks for watching this video.